Hi. It is our number fifth part of our lecture series on the topic of calculus for full. This is the number fifth, right? Calculus for full, right? Okay. So now I'll introduce the geometrical meaning of the sum of, right? The geometrical meaning of sum of. So before proceeding, just it is a continuation of our last lecture, I mean the part 5. There was I had introduced to you the three formulas of the integrals, and the sum of the one of that was sum of x power n dx is actually x power n plus 1 by n plus 1, and number 2 was some constant sum of some constant x power n ds. Actually constant remains constant and x power n is simply x power n plus 1 by n plus 1. Okay. And the last formula was if there is ax power n plus bx power n dx. So this will goes to the constant remain constant, x power n goes to x power n plus 1 over n plus 1 plus the b remains constant here, so b, and then x power n is similar thing. Instead of n you use just m here, so m plus 1 by m plus 1, right? So it was our three formulas in the previous lecture, right? So now I'll introduce to you the geometrical significance or the geometrical meaning of the sum of, right? Okay. So recalling our part 1, right? Part 1 of our lecture, fully all of you know, if it is a big length x and dx means a little bit of x, because the d is a symbol that means a little bit of, so dx means a little bit of x. That means if you cut this large piece of length into a very small pieces, the one of these pieces is called dx, right? The dx is also an dx, it is an dx, and this actually means sum of a little bit of x. That means if you add these very small pieces one by one day you will get the full length of this straight line x, right? It's a very simple thing. And of course, instead of as a length, if it is a very small areas like A, and if you cut these areas into a very small pieces, like these are very big areas, and if you cut these areas into a very small pieces like this thing, then one of these small pieces actually d of a, right? Because d means a little bit, so little bit of a. I mean a means the area of this rectangle, the whole rectangle. So a means the area, actually the full area, right? So actually a means the full area, right? So dA means a little bit of that full area, that means a very small very small pieces of that area, right? It is a dA, it is a dA, it is another dA, it is another dA. Okay, so in that large area, actually here is an infinitely many piece of small area. I mean, a large area contains infinitely many small areas, right? And if you introduce the symbols with dA and the sum of little bit of areas, you will get the full length of the full area of this rectangle. And just add it. dA plus dA plus dA plus dA plus dA plus dA plus dA, and here is the dA plus dA plus dA plus dA plus dA. So infinitely many dA, right? Infinitely many small pieces here. And if you just add it, these very small pieces, you will get the full areas of this rectangle. And the sum of little bit of areas, you will get the full area. Okay? Okay. Now, in our just previous lecture, previous means the part 3, probably the part 3. Okay. In the part 3 lecture, I had introduced to you a graph, right? Slope and the graph, etc. And there was, I introduced a coordinate system, right? It's a x coordinate here, it's a y coordinate here, and if y equals to 2, then all of you know the graph of this thing, right? It is, just name it 0, 0 in origin, that is x is 0 and y also 0. It is a 1, it is a 2, it is a 3, it is a 4, it is a 5, it is a 6, it is a 7, and many more things. It is a 1, it is a 2, it is a 3, it is a 4, it is a 5, and 6, and so many. So, what will be the graph of y equals to 2? It is very simple. This straight line represents the y equals to 2, right? Because all of these points in that straight line is same height, right? Y equals to 2. Okay. Now, if I ask you what is the area in between x is 3 and 5, what will be the area under the graph in between x equals 3 and 5? It is very simple. Just draw a straight line from 3 on the curve and 5 from the curve. Okay. So actually, you want to calculate the area of this chunk. The area of this chunk, right? Okay. So this is very simple. All of you know what is this thing. Okay, just is a 2, it is 2. Just change the values. I just asked you the area in between x equals to 3 and x equals to 6, right? Okay. So what will be this? It will be under the 6, right? It is. Okay. Okay. So you guys are very smart. It's just simple. It's a rectangle, and all of you know what is this area actually. This 2 is the height here, and is the 3 is the length here. It's a 6. The area is a 6, right? 6 unit. It's a one way to calculate, because you guys are very smart. Just a 2 and this is a 3. The length, I mean the length of this baseline is a 3, and just 2 into 3 is a 6, because it's a rectangle, right? But another way to proceed this problem, just calculate the whole area from this line. The whole area from this line, I mean from x equals 0 to x equals to 6, right? The whole area. I'll just put it a dot here, right? Just put it the dot here. Okay. So the whole area of this thing actually goes to 2 into 6, right? 2 into 6. And if you subtract from 2 into 6 to this area, right, I just cross it. Okay. So this dot means 2 into 6. The dot actually, the dotted area, and this 2 into 3 here is a crossed area. 2 into 3 here is a crossed area. Crossed area. And if you subtract from 2 into 6 to 2 into 3, just 2 into 6 minus 2 into 3, that means it is a 6, right? Actually, in previously you calculated the 6 here, and if I calculate from the full area of this thing with minus this small area, the crossed region, obviously you will get these areas, right? Because the full area of this thing and minus this thing, right? So all of you know it will be happening in this area, right? You will get this area. Okay, so actually 12 minus 6 unit, right? So actually this thing, 6 unit. So this is another way to proceed with this problem. It's another way, right? Okay. Now, just think, if you, okay, so now I'll erase some calculations here. Just I erase, this is dot, right? Dot and cross. Okay. Now, if it is obviously a simple geometric problem, but if you introduce here, there is 3 here, it is a 3, and there is a 6 here, there is a 6. But if you actually you just calculate this area, it is our task to calculate this piece of areas, right? Okay. So now it is a very big area, right? It's a very big area. So just cut this area into very small pieces, like this and this and this and this and this, right? So it is actually okay. And what is this very small area actually? Okay. So actually the height is actually 2, right? Height is actually 2. And what is the length of this thing? It is a 3. What is the length of this thing? It is actually, if it is a x, then obviously dx means the fraction of x. That means it is actually a dx, right? And the first area will goes, the smallest area will goes 2 into dx, right? Because height is 2 and this is a very small base, very small length. So it is a big length x, it is a very small length and fraction of length, it will call dx. So this is a very small rectangle with area 2 into dx. And obviously the second areas will goes to same thing, the height is 2 and the base is a very small another dx, right? So second areas goes to 2dx, right? And obviously third area is obviously at 2dx, right? So obviously there was a infinitely very small piece of area, infinitely many very small piece of area. And if you cut this very big size of area into a very small size of area in infinitely many pieces, so all of these areas actually goes to 2 into dx, right? It's a very small piece of area. And if you add this very small piece of area with 1 by 1, what you will get? The full area, right? And the addition, and of course you know what is the addition means. This is actually sum of the very small piece of area. It is actually our dA, right? Because the very small piece of area here, if this area is D, I mean this whole area I will call it A, there is a very small piece of area actually called dA, right? So if you add this very small piece of area dA 1 by 1, I mean sum of the very small piece of area 1 by 1, you will get the full area. Okay, the full area A. Okay. Now, so what is this means actually sum of? It is actually sum of means the area under the curve, right? Because the sum of means you just calculate it here, the addition of very small areas, right? The very small areas, you just sum of these very small areas. Okay, so these symbols means actually sum of means just area under the graph y equals to 2, right? Area under the graph, because if you calculate it here, sum over 2 dx, you will get the full area, and this thing. So actually this means sum of this thing means actually the area under the curve, area under that straight line or area under the curve. Okay, so actually all of you know from our previous formula here, if ax power n dx actually goes to a remains constant and x power n will goes to x power n plus 1 by n plus 1, right? Okay. Now, what will happen if it is a 2 dx? What will happen? It is very simple. Here is 2 into dx. If you introduce here into 1, then nothing changes, right? First of all, it is 2 into dx, and if you introduce here just 1 and multiply it with 1, just nothing changed here, because 2 into 1 means 2, dx means dx. And the 2 into x, 1 means somehow x power 0 into dx, right? So what will happen here? Just a formula. It means 2, just constant, and x power n, the n means 0 here, right? So just a similar thing. So 2 remains constant and x power 0 goes to x power 0 plus 1 by 0 plus 1. That means simply 2 into x, right? 2 into x. And it is very simple, right? And just if you calculate the 2 into 6 minus 2 into 3, that means 2 into 6 minus 3, right? Just 2 is the common factor over this 2 term, 2 and 2, just common it 2, you will get 6 minus 3 here. There is 2, right? The same thing, proceeds. There is 2. Okay, so 2 into x means 6 minus 3, right? Okay, so actually it will go the area under this curve in between x equals to 3 and 6. right? So it is 2 into 3, that means 6 units. Okay. So it is a very simple graph actually. Y equals to 2. It's a straight line, and obviously you think calculate it. Just a very this is a rectangle and just height into length 6. And if you introduce here, this is the very small areas, and the sum of the small areas will get the full area of this thing. The sum of this small area means this thing, and this is then procedure to calculate the area, right? Okay. So now what I calculate this thing actually, it is actually okay, just I raise something, and now I will tell you what is this thing actually. So if it is a graph x and y, it's a 0, 0, it's a 1, it's a 2, it's a 3, it's a 4, it's a 5, it's a 6, this 1, it's 2, it's 3, and it is a y equals to 2 here, then I just calculate the area in between x equals to 3 and 6. It is just this thing, and the one way is to proceed. It is just 2 into 3, I mean 6, or the full areas of these full rectangles, that means 2 into 6, and just from it, if you subtract these areas, you will get these areas, right? So from the whole areas, if you subtract from these whole areas to these small areas, you will get these areas. Actually, small areas actually 2 into 3, right? The height is 2 and this is the length 3, so the 2 into 3, and if you subtract it, so the 2 into 6 minus 3, that means just 2 into 3, it's a 6. And if I just introduce here, I just cut these areas into very small pieces. So one of these pieces actually are 2, and this is a dx, right? It is a very small fraction of x, it's a dx. So this very small piece of area actually becomes 2 into dx, and then second area becomes 2 into dx. And here is all of this very small piece of area actually 2 into dx, right? And if you add this very small piece of areas one by one, so one day you will find the whole areas. And to calculate this thing, I will introduce here 2 dx, right? Because it is a very small piece of area and sum of here. And after the long process here, you will get lastly is a 2 into x, and instead of x you just impart here 2 into this 2 remains constant, and x is a from 6 to 3, right? From 6 to 3, because actually I calculated this thing with the whole areas of this large rectangle. So it's a 6 actually, it's a 6 actually. So from 6 x equals to 6 to x equals to 3, right? From x equals to 6 to x equals to 3, then you will get these areas, right? So x means 6 minus 3. From x equals to 6 to x equals to 3, just it is, right? Okay. Okay, so it is just a calculation. Then I will proceed with another example. Another example to find the areas. Okay, so if I just draw a graph here, x and y, and if I'll draw y equals to x, right? So it is a straight line, obviously. It's a 0, comma 0 is the origin, it's a 1, it's a 2, it's a 3, it's a 4, it's a 5, it's a 6, it's a 7. And of course it is 1, it is 2. I'll just save scaling here. 3, 4, 5, 6. And if I just draw this graph with our previous sense, the 1, 1, 2, 2, the 3, 3, okay, sorry, 3, 3, 4, 4 here, is a 5, 5 here. And if you just draw this straight line over here, you will get y equals to x, right? This graph named y equals to x. And if I ask you to calculate the area under this straight line from x equals to 3 to x equals to 5, right? X equals to 3 to x equals to 5. Then what you will do? Just draw a straight line from here and straight line from here. So you just find out the area of this thing. Okay. So what you will do? Maybe it is actually a trapezium, right? So your class 9, 10, 7, you just calculate the area of this trapezium, you will get the areas. Or another way, okay, another way, what is the another way? Another way was, if you calculate this big triangle, the area of this big triangle, right? The area of this full triangle, I mean, I'll just dot it here. The area of this full triangle. So it is a right angle triangle, and the area of this full triangle goes to half into base. It's a 5 actually. So half into base into height. So if x equals to 5, then the graph y should be 5, right? If x equals to 5, then y should be 5. So if x equals to 5 here, then the height will goes to 5, right? So obviously half into base into height. I mean half into 5 into 5. You will get the full area of this large triangle, and if you subtract from it to this small triangle here, I mean it is just the crossed area. Okay. So just what is the crossed area? Well, it is a half into just 3 into 3, right? Half into 3 into 3. And if you subtract it from here, half into 5 into 5 minus half into 3 into 3, you will get, hopefully, it is a large area. And if you subtract from this large area to this thing, you will get, obviously, it is our areas, right? These are our areas. Okay, so what will you get? This is 5 into 5 means 25 over 2 minus 3 into 3 means 9 over 2, that is 16 by 2, that means 8, right? Okay. So now, if you calculate it with our sum of, it is very interesting, right? Just erase this cross and the dot and the curve like this thing, and just find it. I want to calculate the areas of this thing, right? The areas of this thing. Okay. So just, it is a very big areas, right? And just please cut these areas into very small pieces, right? Very small pieces. One of these actually is this. One of these actually this thing. One of these actually this thing. So actually, if it is a full length, full areas, actually the A, then the very small piece of area will be called dA, right? These are little bit of areas, and if you just add this very small piece of area with one by one, you will get one day the full area of this chunk, right? The dA plus dA plus dA plus dA, I mean the sum of the dA, right? Okay, sum of this d actually. Okay, so it is the x actually. It is a x because it is a very small fraction of this large x. So it is a dx, right? Very small fraction of x. And then actually you just imagine this height actually the changing. Here is this thing, then the next height is this thing, the next height is this thing, the next height is this thing, next height is this thing. Height is increased ever and ever with y equals to x, right? Actually, height is changing according to a relation y equals to x, right? Okay. So it is not a constant height. Height is changing y equals to x according to a relationship y equals to x, right? Okay. So this dA means, first of all, it is a just here, just if imagine a point is a x comma y, just target point here x comma y, right? It's an x comma y, right? X comma y. And what is x actually? If you draw a perpendicular from this point on the x-axis, it is a x, right? Okay. And then what is the height of this thing? It is actually your y, right? Because this coordinate of this point actually x comma y. So the height is actually y. And if you consider a very small area, this very small area in that region, right? The very small area. So the base length actually dx and the height almost remain constant, the y, right? Almost remains constant because I decided the very small area, the almost y. Okay. So what is this arbitrary actually? Y dx, because the height is y and it is dx, so the arbitrary area goes to y dx. So the dA means from the arbitrary area is a y dx, right? And what is y actually? Y means x. It's an x dx. Okay. And if you calculate these small areas from these areas to this part, from these areas to these areas, right? I mean from x equals to 3 to x equals to 5. Okay, so all of you know what will happen here. It will goes the x square by 2 according to our formula. X power n dx goes to x to the power n plus 1 by n plus 1. As the x means x power 1 and correspondence with this thing is a n, just x square by 2, right? Instead of n, you write 1 here. So x to the power 1 plus 1 means x squared by n plus 1 means 2. So it is a x squared by 2. That means half of x squared. And for our previous calculation, just put here instead of x, it is our 5, right? It is a final, I mean the large triangle with x is a 5. So it is x is a 5, then 5 squared, and it is the the small triangle here, x equals 3, just put it just minus x equals to 3 squared, right? So this means half into 5 into 5 minus 3 into 3, right? It is actually equals to half into 5 into 5 is minus half into 3 into 3. So ultimately you will get half into 16, that means 8 unit, right? Okay, so this is actually our calculation to do what is the meaning of this sum of. It is the area under the curve, or area under something, area under the curve actually. So if you calculate the area under the curve, you should go this process here, and just in the end you will find the result and just put it here from the large x to the small x with minus signs. Just instead of x, you just write large x 5 and the small x 3. Just same thing you will get. Right? It is just the previous situation. In the previous situation, it was there is x, there is y, and there is 2 here. The curve name y equals to 2, and you want to calculate the areas in between x equals to probably 3 to 6, I think. Okay, so it is actually, and you just the answer will be 6 actually, because it's a 2, it's a 3. Or if you calculate it with a very big triangle, areas of this big triangle is a 2 into 6, and from it if you subtract this small triangle, 2 into 3, you will get 6 units. And if we will do with our sum of this 2 into dx here, because the 2 and the dx very small length here, 2 into dx, 2 remains constant, dx goes to sum of dx means x, and instead of x you will write the large length of x minus small length of x, minus 3 minus 6, and it is a 6 unit. And here the same thing, right? Instead of 5, it is now from this, for this calculation, it is x, it is y, and it is y equals x. It is 3 here, x equals to 3. It is x equals to 5 here, and you want to calculate this area. So just y equals to x, put it here, and this x square by 2, and x square means instead of x, just press it to that the big x, and 5 subtract the small x 3, and you will get same result, right? So actually our today's lecture is about the geometrical meaning of the sum of. It is actually the area under the curve. Okay, area under the curve. Okay, so now for our another example, if I introduce a graph of y equals to x squared, right? Y equals to x squared, and if I asked you to calculate the area, it is y equals to x squared, right? If you draw the y equals to x squared in your coordinate system, you will get this type of graph. And if I calculate, it's a 0, 0, 1, it's a 2, it's a 3, it's a 4, it's a 5, it's a 1, it's a 2, it's a 3, it's a 4. And if I ask to calculate the areas in between x equals to 2 and x equals to 3, that means here. So it will be a very interesting because you can't find this area with your geometrical sense, right? Because it is not a straight line, it is a curve. You can't find this area in your geometrical sense, right? Okay. But in our part 3 lecture probably, I have introduced a curve means a curve contains the infinite number of points, and in between 2 points there is a straight line. Just in between 2 consecutive points there is a straight lines, right? Okay. And if it is a point and it is a point, and if I introduce a point just besides this point and just 2 consecutive points here, so you will get a straight line here, right? Right. And then if I introduce another point of just beside the second point here, it is a straight line, right? Because a curve means a curve actually formed with a very small straight line in between 2 consecutive points, right? So it is another straight line and another areas. So just break these whole areas in a very small piece of this area and just add this very small piece of areas, right? So what you will do? Just simple sum of a little bit of areas. And what is little bit of areas? It is a dx, right? It is a dx because it is a full length x, and it is a just fraction of x, it is a dx, right? Okay, and now just take arbitrary point here, it is a x comma y, right? It is an arbitrary point here, x comma y. And what will be the x? Just drop a perpendicular from this point on the x-axis. It is a x. The height is actually y because the coordinate of this point is x comma y. And just take consecutive point here, right? Just a consecutive point. I mean, if you just take the consecutive point, you will get a straight line here. And of course, the area of this straight line, area of this small pieces, just I calculate in that previous case, it is a y and dx. This is a y and dx. So dm is, for the arbit case, is a y and dx. And what is the y actually? Y means x squared, right? It is x squared dx, and all of you know from our formula number 1, it will goes x cubed by 3. Okay, that means 1 by 3 x cubed. And you want to calculate the area of this chunk from x equals to 2 to x equals to 3. So just press it, just put it instead of x, large x, I mean 3, minus the small x, I mean 2. The large x is a 3 with minus small x, it's a 2. That's the same thing. So 1 by 3 is x cubed, means instead of x you will write 3, minus instead of x you will write 2 here. So it's a 2 cube. That means 1 by 3. 27 minus 8, that means 19 by 3 unit. Yes, it is your answer. Okay, so actually sum of, I mean this symbols sum of dx of y, anything is x squared, x cubed, x and somehow. So it means the area under the curve of y. Okay, area under the curve of y. Okay.